In the previous lessons, we've imported our Boston house price dataset into our Jupyter notebook. And now that we've successfully gathered our data, it is time to take a good, hard look at it. And this is really the next step in our workflow. We've formulated our question, we've gathered our data. Now it's time to explore our dataset in depth. And oftentimes, we're going to be exploring, visualizing, and cleaning this data more or less at the same time, simply because the problems that the data has only becomes apparent after you start digging into the dataset. Okay, so imagine that you're back at your real estate job and that the office intern has just plonked down a big dataset on your desk. What are the first things that you'd want to understand about a fresh dataset? What's a good starting point to get to grips with a dataset that you've never seen before? What are the kind of questions that you'd want to ask when you're first starting out with your work? Let me show you my own starting point. Let me show you the first 6 questions that I ask myself when I first start working with a new dataset that I haven't seen before. The first question I'm going to ask myself is, where does the data come from? What's the source of the data? The second question is, can I find some sort of short description of what's in the dataset? And this is important for understanding the all-important context under which the data was collected and also how the data was collected. Third, how big is the dataset actually? How many individual data points are there in the dataset? Am I dealing with an enormous dataset or a small one? This is important from a practical point because working with a dataset with 10 million data points will require very different techniques than working with a dataset of, say, 10 data points. For starters, my aging laptop will totally struggle to crunch like a huge dataset. So it's important to figure out what sort of beast you're going to be dealing with. But this aspect of dataset size is not just important from a practical point of view, but it's also important from a theoretical perspective, because many statistical tests that you're going to be using will become a lot more powerful as the sample size increases. The fourth question is, how many features are there in the dataset? Now, what do I mean by features? Well, for each data point, how many aspects were measured? How many entries are there for each row in the table? How many columns are there? This is what I mean by features. You and I are going to be looking at house prices shortly. And each house is going to be in a row in this dataset. The number of features will tell us how much information we have about each house. The number of features will help us figure out how many characteristics we're going to be basing our prediction of the house value on. The next 2 questions we're going to ask ourselves are, what are the names of the features and what are the descriptions of each feature? The reason these questions are very crucial is because we need to understand what the dataset is actually measuring. So sometimes you'll get datasets with pretty unintuitive measurements. So it's important to kind of dig in and understand what exactly is contained in the data. For starters, you'll probably want to check the units that are being used in each column. So, for example, is our price given in dollars or in thousands of dollars? And these are just some of the basics to get right. Okay, so now that we've got our to-do list, let's return to the Python code and see if we can answer these initial questions and check them off one by one. There is a handy little Python function called dir that we can use to look at a Python object's attributes. Check it out. dir parentheses Boston underscore dataset and shift enter will bring up the following output. It'll show us a list of attributes. What we're looking at here is actually a list of attributes for this Python object. The first attribute here is a shorthand for, I'm guessing, description. So let's pull this out. Let's print this out. I'm going to say print Boston underscore dataset dot DESCR, all caps. And let's take a look at what we see here. So using this Python attribute, we do indeed get a description of this dataset. This description was included in the Python object, and we were able to access it with this attribute that we discovered through the dir function. Okay, so let's take a look at these notes. We've already seen that there are 506 instances or rows in this dataset, and there are 13 attributes, 13 categories or columns. Now, these 13 columns are as follows. We've got per capita crime, we've got concentration of nitric oxides, so this is a proxy for pollution. We've got the average number of rooms per dwelling. We've got a pupil-teacher ratio by town, so this is a proxy for the quality of the schools, and a whole bunch of other attributes. Scrolling down a little more, we see that the two researchers that collated this dataset are Harrison and Rubenfeld, and that this is based on a research paper. In fact, we can actually see the title of the original research paper here, Hedonic Prices and the Demand for Clean Air. And this was published in the Journal of Environment, Economics and Management, Volume 5 in 1978. So this already answers a lot of the initial questions about our dataset. It's actually fairly interesting that the original purpose of the researchers was to figure out how high the demand was for clean air in Boston. That's what they were trying to accomplish. They were trying to figure out how much more people are willing to pay to be able to breathe clean air in the city. The other thing that's important is that this housing data dates back to 1978, and that we're working with 506 different entries. So let's check off the questions on our list. We've figured out the source of the data. We've read a brief description of the data set. We've also managed to figure out the number of data points in the dataset, which was 506, and the number of features, which was 13. And lucky for us, the descriptions of the features was also given. They called them attributes, if you remember. And the names of these attributes were given in all caps. They were abbreviations. And finally, we had a very brief description of all the features as well. So I think for starters, this is pretty good going, but let's crack on. Now, as an aside, if you're curious on how this dataset was originally used, you can actually pull up the original research paper that is mentioned in the description. So I just Googled it and I got sent to the University of Michigan library website. And there I was able to pull up the PDF for the original paper for free. And I think that's because Daniel Rubenfeld was actually at the University of Michigan, while his co-author, David Harrison, was at Harvard at the time. Now, if you Google this as well, let me show you how you can embed a link in your Jupyter Notebook very, very easily. So I can copy the URL here, go back to my Jupyter Notebook, and then going into one of the markdown cells, say the gather data cell I've got here, I can use some square brackets and some parentheses to insert my URL. So the URL goes between the two parentheses. So I'm going to paste it in here. This is the URL that I copied from the other tab in my browser. And then in the square brackets, I can include the text that I want to display instead of this long and unwieldy URL. So I'm going to write source, original research paper. And when I hit Shift Enter, it's going to be displayed like so. And this is an active link that we have now in our Jupyter Notebook. Now, you might not always get a nice description along with your dataset like this. So let's have a think about how we might look at the number of data points and the number of features manually, in case it wasn't presented to us on a silver plate like this. Going down to the bottom, I'm going to insert another markdown cell, and I'm going to add a subheading here. And this is going to read data points and features. To look at the number of features in this dataset, I'm going to first access the bunch objects data attribute. I remember seeing this up above when we used the dir function. So we can write Boston underscore dataset dot data. And this is what this would look like. From the output, we can see that it's an array. And we could verify this by writing type and then surrounding Boston underscore dataset dot data by parentheses. And here we can see that it is in fact a NumPy n-dimensional array. This is the type of object that we would be accessing like so. Now, if we wanted to see the number of rows and columns, the easiest way to do this is by writing Boston underscore dataset dot data dot shape. Shape is an attribute of a NumPy array, if you recall. So hitting Shift Enter, we can see that this array has 506 rows and 13 columns, which is good because it ties out with the documentation that we read earlier. The thing that you'll also notice in this line of Python code is that we are chaining our attributes. I'll just add this as a comment here on the right-hand side. Now, this is something quite important to understand, because this is a good example that shows how objects and data can be nested inside one another. Scrolling to the very top, we see that when we are working with the Boston underscore dataset, we are in fact working with an object of type bunch. And this bunch has a number of attributes, including the data attribute. This data attribute is in fact an object of type ND array, a NumPy n-dimensional array. And the n-dimensional array in turn also has attributes, including a shape attribute. And when we call on an ND array's shape attribute, we get back a tuple. So when you see this dot notation being used to chain things together, you can think of it almost like a Russian matryoshka doll, where each doll contains another object. And if that's not your kind of thing, then think of it maybe like the movie Inception, where you had dreams within dreams, just with less gunfire. And on that note, I'll see you in the next lesson.